Now we welcome the final speaker of the morning, Maria Ikonomopoulou. She's head of Translational Venomics Group at the Madrid Institute of Advanced Studies in Food. And she's going to talk about something that I think is fascinating, which is the use of venom, of poison, animal poison, as a medicine. Maria.
Thank you, Adam. Thank you, everybody, and for the patience to be here and stay in the last talk. So, since Adam very nicely pronounced my last name, as you probably figure it out, I am Greek, but I live and work in Spain, and more specifically in the Madrid Institute for Advanced Studies in Spain, or INDEA Food, as we say it for shortcut. And in our research, we use animal venoms to identify compounds that they can be used as drug candidates or as tools trying to understand aging and aging-related diseases. So before I tell you why I'm fascinated and the huge therapeutic potential of animal venoms, I would like first to say how I started, and this is something that I always say when I mentor the younger now generation, women in science, because I didn't have very linear progression. So I studied in north of Greece, in Florina, agricultural technology, with more focus in animal production and biotechnology. And then I moved to Australia for my postgraduate studies. So I went to the University of Tasmania, where I studied zoology. And then I did my PhD at the University of Queensland, which was endocrinology and toxicology of marine turtles in Australia and Peninsula Malaysia. And after that, I did first a short postdoc, which was in biomedicine. And then I found my niche, which is the animal venoms and their potential. First, I studied their agrochemical properties to be used as bioinsecticides, and then later I moved into the medical world. So I'm investigating since then for the anti-cancer, and now in Spain, anti-aging potential. But why am I so fascinated about them? Let me see. So I'm not just the only one. If you see through the mythology and the different civilizations, you see the Greeks, they believed in the gargot, which was a mythical creature that it has all these snakes in the head, and if someone looked at it, then it was freeze, it became a statue. But in other also civilizations, in India, they're really celebrating the snakes. And you could see statues of Vishnu or Shiva that they're decorated with different snakes, or as the source of the evil, you see the god of light, Ra, in Egypt is killing the god of the darkness. And nowadays we still like, many of us, the venoms, and many people, you can find some really fancy tattoos, to decorate different parts of the body, or there is a really nice jewelry collection. Some of them are really beautiful, and some of them, it's in the eyes, the beauty of the beholder. But still, and some other people like them so much that now, just think about it, when you go for lunch, they're actually eating them. And I really believe in some Asian countries, there are some master classes, where you can make a tofu with a scorpion potentially here, or a snake in a stick. But even if you don't want to eat them, you cannot quarrel that, they do have medical properties and goes also very back in time. So in Greek mythology, the Greek god of medicine was Asclepius, and you could usually see his rod is civilized is enwrapped by a snake. And then nowadays we have also all the different medical associations and societies in America and other parts of the world that they have adopted, a similar logo. And also in the traditional medicine, you see in South America, but also in Chinese medicine, they are using the venoms from different animals to treat different conditions and different diseases, or different parts of the venomous animals. So you see, just put some examples that I just randomly pick up from the internet. They use even to prolong life, for treating arthritis, or you can see asthma, pain, cancer, and of course they can use to improve your eyesight, or to increase your vitality, and so on, or even to remove toxins. And it is true, they have a very wide documented potential and applications. In pharmaceutical, just some of them, they have been studied and investigated as analgesic, as anti-cancer, for metabolic properties, immunomodulating, and so on, as a tool also. So a very famous example is actually a peptide from a scorpion, that it has a huge specificity towards glioblastoma cell. So now it's got approval, I think, in USA, that they're using it as a pain tool. So the surgeons during surgery in the theater, they can see the glioblastoma cell easier, and they can actually remove the cancer. But also, as bioinsecticides, there is an approved bioinsecticide in USA that is coming from the spider Venom, a spider peptide, and as cosmetic. In many Asian countries, you know, they use it for as a whitening, for skin whitening or depigmentation conditions. So indeed, that's not surprisingly, there are 13 FDA and EMA-approved venom-derived drugs in the market for treating different human diseases and conditions, from hypertension, thrombosis, acute coronary syndrome, chronic diabetes, anticoagulant, and many other at different stages of preclinical and clinical development. One probably of the drug that you have heard a lot today is actually the Ozempic, the big blockbuster drug that has been used initially for treating diabetes, but now is a big thing in USA, especially for helping to reduce the weight. But what you might not know is actually coming from a venomous lizard. It's a peptide from a venomous lizard from South America, the Gila monster. So I hope now I'm getting to convince and get your attention about the real potential and scientifically approved and scientifically validated. So in our team, we believe in harvesting the nature in a sustainable way to identify bioactive compounds that we use it for biotechnological potential, but in the future we want to expand also to test them for their cosmetic application. So besides myself, that I mentioned that I have a strong background in animal biology and biotechnology, is Javier, who is pharmacologist, Isa, biotechnology, Sabella, who has studied human genetics, and Pepe, who is a technician, animal technician. But we also have, which I haven't shown here, many students that they come through to do as part of their degrees, and I'm going to talk about it later, and we train them and we mentor them as well. So we use all kinds of venomous animals. So some of them are very cute, and you might know the male platypus, they actually have venom, and it's very powerful. Some of them, not so cute, you know. But they still all have very powerful, very strong, and fast-acting and potent venom. I mean, just an example to mention that this ant is a bullet ant. And it takes its name, as you can imagine, because people who have been very unfortunate that they have been hit by a bullet and also been bitten by this fellow said it has a similar type of pain. But also in the sea world, we have a lot of animal venoms we are working on, and I'm going to talk about one of our candidates that comes from the octopus species. But just to make, if you just go to YouTube and you check some corn snails and the venom, you can see that the moment they just envenomated the fish, it's just instantly paralyzed. It's just really fascinating and scary to watch it. So what we do is we have two main objectives. First of all, is to identify, as I mentioned, novel candidates that they could have applications in aging and aging-related diseases. And we're focusing on cancer, in melanoma, BRAF mutation, which is the main skin cancer, and of course, senolytics. And if you haven't heard about senolytics, we're looking for compounds that they specifically eliminated the zombie cells that we have in our body. And as we age, they accumulate, and they do contribute to many aging-related diseases. They cause dysfunction of the organs and the tissues and so on. So there's a huge interest to find new senolytics. And of course, we want to build a very diverse and large venom biobank that we can use for different biotechnological projects. And this is our platform. I'm not going to go through that, but I just want to say that either we can work with the crude venom, which is actually a mixture of different compounds, small peptides, proteins, salts, enzymes, or through bioinformatic approaches, we can just start working from the beginning with the pure compound. And then what we do is, if we don't have the sequence, we want to identify it and then to synthesize it in the lab, and that in sufficient quantities so we will be able to characterize it in detail, to study it, find out how it works, and then to optimize it. We want to have better analogs, that they're safer, very fast acting, and validate it later on. So one of our candidates that I want to talk a little bit about comes from our interest in finding solutions for melanoma. And as I mentioned, it's one of the main and deadliest skin cancers, especially when it's metastasized in the body. And the problem with melanoma is that when it's metastasized, the current drugs, they anti-cancer, all kinds of cancers, eventually the patients develop drug resistance and the cancer comes back. So, and of course, the other drug candidates or other regimes that are used, many times it becomes toxic for the patients, and then the clinicians have to stop their administration. So there still is need for new approaches and drug candidates. So we have found out a small peptide is actually coming from the octopus species. And what we have, I'm not going to talk about the scientific part, but basically what we found out is very safe in the body, even at really high doses, which is like in contrary what's happening with the normal drugs, is 100% biological origin, even though it's chemically synthesized in the lab, meaning that we count on years of evolution for refinement of the specific targeting the melanoma cells and having no effect on the healthy cells in our body. And of course, it's very specific, as I mentioned, and fast acting. So before I close, I just want to say that besides in our team, we have a lot of students that I mentioned that we are training, and as part of their degrees, for example, we have master students or bachelor students from biotechnology, biology, pharmacology. And what they do, they come and they learn new skills, new technologies, so then later on they can be more competitive and have more chances and better chances of employment. And also, as I'm part of the higher degree research mentoring system in Australia, I'm also through video conferences now. I'm not traveling so much in Australia. We always have students that I give them some options about their professional development and career options. So if you want to hear more about research, please feel free to reach out. Before I close, I want to thank, first of all, my family for the support, because as all women, we need to have a supportive environment in order to be able to do our research. Of course, the organizing committee, Eva and all the team, Sonia, Susanna, Chris, for the opportunity to be here among all these great and inspirational women. And of course, all of you for your attention. Thank you.